Okay, now we go to the test 14 number 2 and look at the question number 2.1. Three identical balls are thrown from the top of a building, all which the same initial speed. The first is thrown horizontally, the second at some angle above the horizontal, and the third at some angle below the horizontal. Neglecting air resistance, rank the speed of the ball at the instant each hit the ground. Okay, so you can use the conservation of energy to solve this problem. So let's do it here. Okay, you throw a ball with the initial speed of v, and the ball hit the ground at the height of h, like this. If this is the initial speed and the final speed of the ball is Vf, from the conservation of energy we have 1/2 of m vi square plus mgh equal to 1/2 of mvf square. At the ground we use this as a reference point, so the gravitational potential is 0 here, which means that h is 0 at the reference point. So we don't have the term on the line of the equation. We don't have the term of the gravitational potential. And from this equation you can see that Vf depend on vi square and h only, and there's no direction here. You can see that it is no direction involved in this equation. So it means that we don't care about the direction. If you have the same initial speed and the ball is thrown from the same height, whatever the direction is, you will have the same Vf. So it means that the answer should be they will have the same speed. Okay. Now move to this equation 2.2. A log of mass m is dropped to the ground from height h. A second log, which mass 2m, is dropped from the same height. When the second log strikes the ground, what is its kinetic energy? Okay, we can use the same principle to answer this question. They say that the first log with mass m drop from the height h to the ground, and they ask for the kinetic energy, right? So you have this is 1/2. No, you may start from the mgh. It means that initially the rock has only the potential energy, and then it change to the kinetic energy. Okay, so when the rock strike the ground, the velocity can be computed from this equation. Now, look at the second rock. It has a mass 2m. Okay, the mass 2m, and what is the velocity when it strikes what is the kinetic energy when it strikes the ground? And you can see that we can use the same principle. 2mgh is equal to the 1/2 of 2m v square. Okay, so you can see that this is the kinetic energy of the second rock, which equal to the 2 times of mgh, which means that the kinetic energy of the second rock is 2 times that of the, or twice that of the first rock. So the answer is A.